Okay, hello everyone. So welcome to RISC-V BoF. I'm just starting, but I'll just be the smallest time taker for things. So yeah, this is BoF. So all RISC-V topics. So the agenda is something interesting that we did in GCC 15, which we never got to describe. Constant synthesis, which is like an interesting topic, let's say, in the RISC-V backend, and updates on the auto vectorizer work that Robin's been doing, what we've done, what's in works, and what to look forward to. So this is a generic SCED1 change that I worked on. It is not RISC-V specific, but this is something that happened in the context of RISC-V work, so here we are. So it started with our Revos perf projection team, and they were very upset with the compiler people because the CAC2 benchmark was twice. We only had I counts back then, obviously, so we were like double the I counts versus AR64. Obviously, ISA cannot explain this, right? I mean, how different can the ISAs be, right? So it was the delta was just load stores, and nobody understood why. So now it seems when I talk to people about this, it seems that the problem was sort of known by other people over other architectures over time, and I think Jeff suspected SCED1, and most of the times he's right. So. Yeah, in my interactions. Okay, let's put the disclaimer. So indeed, with SCED1 disabled, we got down to like almost the same performance, and so clearly there was something wrong with SCED1, and Robin had enabled SCED pressure already, which seems to address some of it, So despite that, we were still seeing this anomaly. So on investigation, it turned out to be all spills, which was all SCED1 induced. The trick was to use this SFP marker in the safe temps. That's just to verify that it's a spill. A prior patch which I had done some mitigation, some spill mitigation, as in reducing the cost of the spills, but still we had too many spills. And the challenge was to just distill this 1 trillion delta to like one.
It was one static load store?
Yeah.
That caused it?
No. It was. I distilled it a test case.
Okay. I thought there was one static load store.
No.
That caused a trillion.
No. The other way around.
That would have been a hot loop.
Yeah. So it was the other way around, right? So many of those one load stores were causing those spills. So yeah, I created a PR and then got down to it. So basically, the gist of the problem was that in that reduced test, we saw this one extra spill in the outer loop because the inner body was allocating this A1 register, which it did not have to because the A0 define and usage was too far apart, and they didn't need to. And it took many months actually to figure out where the actual problem was, and this model set excess cost, which is in the pressure sensitive scheduling code, it has a heuristic where it actually deliberately ignores pressure. To me, it was like a bug or a heuristic over eagerness, but Richard Sandiford didn't agree. So
and unlike me, Richard Sandiford is right all the time.
That is true. So the compromise was to have this param. Apparently, he thought that this is because we were not modeling the pipeline or whatever correctly, and then it was just an artifact of that. I still disagree, but anyways, so.
Actually, I think we did start off just. Oh, yeah, I'll do it. I need a little exercise. I think, Vineet, and correct me if I'm wrong, but I think we started off with that, and then at some point we were discussing out of order, in order, and I think we actually convinced Richard Sandiford that he was wrong.
Well, I don't think he admitted he was wrong because
Oh.
we still ended up with the param. Otherwise, it had been code deletion in the past.
Okay, all right. Well, again, all right, so I was wrong again.
And he retired, so maybe I can sneak my in.
Last comment in, and then retired, so we couldn't.
He won the game.
Yeah, true. Yeah. It's okay. So, anyways, we have a mechanism now to disable that heuristic, and so that disabling of heuristic is enabled in the RISC-V port right now. I would encourage the other backend guys, if they are here, to please give it a shot, give it a try. It works.
So the patch is not in.
It is in. It's been.
is it?
It landed in 15.
Oh, but you have to use
This param, it's not unconditional.
default for us.
It's default for us, but non-default for everybody else.
Oh, okay.
Yeah.
We're doing the right thing.
Now, question.
Sketch pressure, so when I was on power, we ended up having to use it as well. And there were issues with it that we
Yeah.
ended up fixing. Probably not a problem with RISC-V, but we had issues of the sketch pressure underestimating how many registers we had.
That-
Because power, we have 32 or 64 vector registers, depending on whether you have AltVec or whatever. And it was always because of it was using reg classes, and it would always use like the bigger one. It's like, oh, AltVec is a subset of VSX registers, so I'll use VSX 64 VSX registers as my register size, and that's the pressure I'm going to go to. But the instruction that we had was an AltVec instruction, could only do that, and so it just went by at 32, and we got all the spills, like you see it had on there. But I guess my main question, is it just power, RISC-V and ARM that are using this? Or did I see that ARM disabled the first
Yeah, they disabled
schedule?
it.
So it's just RISC-V and power then using this? So I think that's why I think
So
when we
ARM
did,
guys disabled SCED 1.
yeah.
They did
well,
not disable pressure-sensitive scheduling. They disabled
but isn't that
SCED
when
1.
it's using?
Well,
This is when this is used.
Where pressure is important.
Yeah.
yeah.
So
yeah,
they're basically not using this then.
they are not using any of it, right?
Yeah.
So they are not using just you. So
So why did Richard care?
They had enabled back then.
Oh.
This is GCC 15, right?
Yeah.
So the discussions were 1 year ago. I think they disabled it later because they were from the patch they were sick of the compile times which SCED 1 blows up, and I think that was the problem.
Because on power, we always saw that schedule, because we saw like Intel doesn't do it and stuff. It was always, schedule 1 was always a benefit for power. And it was a better benefit when we had sked pressure on.
Yeah.
Just one comment, since you mentioned Intel does not enable Schedule 1. That is actually because of the register file problems. It's just too small of a register file, and Schedule 1 will cause the Intel architecture to blow up and just abort.
Okay, I think I need to
Yeah,
finish my
really.
part. So this is just a summary slide of the results. So I measured it on Banana Pi, and you can see it's 18% fewer instructions and 8% fewer cycles on Banana Pi.
So when did this go in? Is this in 15?
Yeah, it's in 15.
It's in 15.
Yeah.
Okay, that's-
And apparently, I think Wilco did try out my patch, and they did see 25% perf gains on Neoverse. Now, I don't know if I did not follow up with him if they enabled it or not, but it was not like one-off. So it's not like specific to RISC-V, it's not specific to spec, it's a general change in instruction scheduling. So, okay. I think that's my part.
So weren't we having problems with the pressure just being miscomputed? That was ultimately what we decided, right?
In this case, it was miscomputed. What I did for the So yeah, I don't want to eat into too much of time, but maybe
you're
a couple of months. So as I mentioned, we are like 1 trillion cycles behind AR64, and this got 500 billion. There's still 500 billion missing, so we are still 500 billion behind them, which is all spills again. And when I investigated the second patch, which actually took 3 months, and I think Jeff mercifully killed it for the right reasons, mercilessly killed it. So anyways, so there is this one existing problem in the not in the model computation part, but in the pressure calculation part is when it tracks the dependencies, it moves the instructions around based on their dependency. Again, this is just to compute the initial register pressure. And it sometimes increases the live range because of the way the code is written. So it's an implementation problem, in my opinion. When I fixed it, I was able to fix it. I was able to recover some of that, but the problem was it could potentially generate wrong code because it was reordering some of the load stores which are loosely tracked in terms of the dependencies. I was just tracking the hard dependencies, and I think in some cases it was moving things around.
Yeah, my recollection is we came up with a case that we would swap
To-
something of importance. It's
Yeah.
all gotten fuzzy.
Yeah, and I don't know why I posted that code snippet, otherwise he would not have seen it. So it's in my patch is to blame. So anyways, yeah.
And I can, actually, we're going to use this for questions, so I guess I will put the mic on.
I'll be running around.
So are we giving up on them, or are we
Oh, no.
some of it?
No, I'm
Oh, the irony is I'll touch on it too. I'll touch on it too, just from a slightly different angle. All right, so one of the things we have seen recently is the RISC-V port tends to use a lot of defined incident splits. First few go in, and then it starts getting copy and pasted everywhere. And this is probably not a good idea. So at the highest level, a defined incident split is literally a defined incident and a defined split. And it was introduced, 15 years ago, to cut down on the amount of duplication we have and the bugs coming from code duplication. And it often looks like a great solution to code gen problems. We use it very heavily in the vectorizer code, where we use it essentially as a late lowering. And that was kind of the path I was trying to go to with move constant internal, was a delayed lowering of constant synthesis. But as we found out over the last couple of years, loops can be deceiving. And the way we're using this construct right now is we're hiding target dependencies from the generic parts of the compiler, particularly the cost of constant synthesis, which on RISC-V can be 5 instructions, maybe even 6. I'd have to sit down for a few minutes and think about it. But it's worst case scenario, 64-bit constant could be either 5 or 6 instructions.
6, yeah. 6.
It's a 6, yeah. But it does give you really good control of the code generation, which Vineet's work has shown with the add sum of S12s. What was it, 300 billion? It was very, very significant by using a defined incident split to synthesize addition of two, or of a relatively small signed immediate, but too big for an S12. So I'm not going to go to the link. I probably should have done this live on my laptop, but there is a link there that shows an example from Perlbench. So I was looking, so we have in QEMU, we have a plugin which will give us instruction mix data, including disassembly and how hot the block is. And I happen to be looking at something and going, why is there a logical AND against the value -1? That's a no-op. Where the hell did that come from? And eventually I traced it down to this instruction we added, or sorry, this enzyme we added in, I think it was GCC 15, maybe 14. I think it came from the vRule guys. And what it's trying to do is synthesize a pattern or instructions to turn off 2 bits. That's all it's trying to do, because we can do that with 2 be clear instructions. Unfortunately, the predicate for operand 2 also matches a constant with only 1 bit off. So what happens? It matches the defined split after reload. So if you remember, a defined incident split is a defined incident, defined split. So after reload, it matches the defined split, runs this split code. And if only 1 bit is off, operand 3 becomes -1. And nothing after split 2 is going to clean this mess up. So if you're going to use a defined incident split, you have to be very cognizant of the fact that you own the code gen problem. If you generate incorrect or you generate inefficient code, nothing's going to clean up after you after split 2. we found multiple examples of this, particularly in the logicals. We've also started playing with some of 2S12s. In addition to,
Is that?
excuse me?
So you split it just by doing a defined incident and a different?
No. What you do instead, because I was going to touch on that in the summary, but I'll touch on it now. It's fine to do it now. The high-level concept is generate the code you want as early as possible. So in the case of these logical synthesis, you want to go all the way back to your AND SI, IOR SI, XOR SI, and generate the simple sequence at expand time. So you widen your predicate for the operand in your expander and say, oh, it's just 2 bits off. Generate 2 equivalent be clear instants from the get-go. So you never synthesize the constant. You never have that defining the split never triggers anymore, and you just go away. Generate good code from the beginning.
Yes, but I have a question.
I'll go. Oh, all right.
Yes, I'm exercising.
So but then this contradicts with the general high-level idea of doing it early or doing it late, right? And it hits the pitfalls of doing things early, right? Then combine has too many things to work with and all that
Yep,
stuff. Right?
absolutely. That is a real issue, and I'll touch on it. That's why it gets hard, because if you break things down all the way to your target too early, you end up with 4 instructions or 5 instants or 6 instants, and combine can only handle up to 4. And that's how some of these defined instance splits got started. So these also interact very poorly with the combiner. So if you have a defined instance split, and oh gosh, I really should put the example in the slide. Maybe I got it on the next one. Nope. All right, so let me back up here. So what we had was a defined instance split that matches a AND instruction with a constant. We don't have that in RISC-V. But there was no way to generate that particular instruction if one of the operands was a constant. So we created a defined instance split which allowed a constant for one of the operands. And it did basically what we wanted. But it prevents combine from squashing that logical AND with complement with nearby instructions. So for example, a bit extraction followed by a complemented AND would never be combined into something simpler. And I assume these slides are going to be available somewhere so people can click through to the link. But what we're doing is we're lying and we're saying, we can implement this instruction that doesn't exist. And the only reason that defined incident split exists is because of move const internal. Move const internal hides all constant synthesis. And Palmer, I know you were concerned about it when it went in. I know you were, with good reason. I think Vineet, you were concerned about it when it went in. But it solves certain combined problems that Vineet was just touching on. If you have too many instructions, you can't combine. If you hide things, you can't combine. There's no great answer here. So anyway, we have the move const internal instruction, and really the point is once you have a single defined instance split, it hides the cost. So when combine is trying to look at a series of 3 instructions perhaps, and you have a 2 instruction sequence that could do the same thing, move const internal hides that cost. And therefore, once you have the first one in, if you want that to combine with something else, everything that depends on it has to be a defined instance split because the cost model has been totally broken. This is bad. And the reason it doesn't work is with the cost model broken, the split code perhaps looks like 2 instructions when it's actually like 6 or 5. And combine doesn't know what to do with that. We could address this by fixing simplify RTX in many cases. And in fact, we should be fixing simplify RTX in many cases. Daniel Barboza is working on one of these problems literally right now. There's several. I think Shreya did one very recently, and just trying to squash out instructions before combine sees them. All right, so what do we want to do? So a couple of quotes that I thought were particularly relevant. Most of you here look You probably remember Henry Spencer.
90s.
Yeah, from the 80s, maybe the 90s. But if you lie to compiler, it'll have its revenge. Who here knows Richard Henderson?
Yeah.
All right, just a few. Richard Henderson was a member of this community for 25 years before he ran off to work on QEMU. But fantastic compiler engineer. And he had the corollary. You lie to reload, and it'll have its revenge. And he was absolutely right. And that's what we're doing. We're lying. Point being is, while it makes it easier for us to generate code in some contexts, the lie makes it harder to do further optimizations. I've probably run into at least a dozen cases over the last year where there's something I could improve, but there's a defined incident split getting in the freaking way. And sometimes a defined incident split is the right solution, but maybe we can do better. And that's what I'll touch on Vinit's problem in just a moment. So what do we want to do? We want to generate good code as early as possible. So if you can do it at expand time, that's when you want to do it. If it's not exposed then, but it's exposed at combine, look at simplify RTX. You might want to look at LRA and reloading. LRA has hooks for certain patterns. That allows you to take control over address reloading. I had suggested to Philip Tomsich at least 3 years ago that might be a solution to some of these problems. What we missed was the correct implementation. Other things we got to be aware of. We got to address limitations of combine. Reg equal notes are only used for a 3 to 2 combined simplification. It's not used for 4 to 2 at all. And if you're going to take move const internal and remove it, and we have 6 instructions to generate an arbitrary 64-bit constant, I've got to have a reg equal note to know how to interpret what those 6 instructions do and optimize around that instruction sequence. Additionally, defined splits can really help because of the way we expose 32-bit ops on RV64. So we have an explicit sign extension on our arithmetic. We have an explicit sign extension on some of the bit manip instructions, like count trailing zeros, count leading zeros, pop count. Combine, if it's trying to use its own splitting magic, it splits it in the wrong place. So we are probably going to have to create some new defined splits to handle some of these problems. But in general, we want to avoid defined incident split. Use a defined incident, use a defined split, don't use a defined incident split. You should only have a defined incident or a defined split, not both. So let's look at, so this comes back to cactu. So this is a bug that Paul Antoine discovered in cactu BSSN, and what he found was we have this the second add-I, totally redundant. You could push the offset into the load, right?
I've seen that exact thing on Power.
Yeah, we see this all over the place in cactu BSSN. Hundreds of billions, billions and billions. I don't have a Carl Sagan voice, but that's what you'd be thinking. So what happened here? The defined in the split matched the SP plus 2048. Right? That's its job. It works fantastic. I mean, it saves hundreds of billions of instructions. Sure. It splits it into 2 add-I's after reload. Nothing after split 2 will ever try to combine that second add-I with the load. That's the problem. There's nothing to clean up after we generate code late.
Yeah.
Go ahead.
So now we have a second combine that Richard added.
Yeah, that doesn't fix this either. It's too late.
Okay. It's too late.
Oh, sorry, too early. Too early. Yeah, so Peter's point was there is a post-reload combine pass. It runs too early to fix this. Okay. The other thing we found was sometimes Sketch 2 will adjust the load to reduce the dependency height, but it leaves the second add-I instruction in there, even though it's totally redundant. Again, nothing's going to clean up afterwards.
And you can't rely on a peephole because they had to
Peepholes
be
are crap.
back. Yeah, I mean, yeah.
All right, so what do we do to fix this? So first, we want to take the expanders for your basic arithmetic and do the same thing we did with logicals. When you see the addition of 2048, turn it into 2 add-I's. Don't generate load 2048 into your register and then do a register add. Generate 2 add-I's from the get-go. Once you put that in place, and if you do that as a function rather than as inline in the pattern, you can then define the add pointer pattern, which allows you to control how reloads are generated. And the idea here is you can generate something like that. And then you remove the sum of two S12 patterns. Sorry, Vineet, it's got to go. Unfortunately, it didn't work. But for a very good reason. So when we use add pointer to generate the reload for us, what we were doing is at reload time, it's FP plus 2047. FP turns into SP plus a small constant. You add that small constant to 2047, it's now out of the S12 range, and guess what? We need address reloads again. And in fact, the first time, I think it was about 100 billion more instructions. The good news is it's really easy to fix once you know what it's doing. You just reverse where the constants are. That's it. Once you do that, when you do the FP to SP elimination, 1 plus that small constant still fits in an S12. The second constant typically goes into your load, and you save another 100 billion instructions on top of what Vineet already got us. Improves performance on the BPI, I think it was 2 to 3%. The sad part, it doesn't make Ventana's design run any faster. So if you're on Banana Pi, this got better. If you're on Ventana, yeah, it's 100 billion fewer instructions, but not any faster. So looking forward, move cost internal is easily the biggest problem in this space. Removal is going to regress things. We know this. I could probably give, if I sat down and reduced test cases, there's probably dozens. What's happened is we have built more and more patterns on top of move const internal. Whoops.
So this is a GCC 17
Oh
topic.
yeah. I mean, we're putting pieces in place now, and we'll put pieces in place as fast as I can. But it's going to take time because we know there are patterns where I've got to see at least 6 instructions, and I can't. I can't do a 6 to n combination. We've got to fix the reg equal issue, or some of these regressions aren't going to get fixed, or we have to put in a bridge pattern. And I'm trying to avoid bridges as much as I can. It's going to require improvements to simplify RTX. So when you start seeing those land, it's all in support of getting rid of move const internal. There are certain bit tests, believe it or not. So one of the things we started doing, when we started trying to remove move const internal, we said, how can we narrow the scope of what we have to look for in terms of regressions? So we said, all right, well, let's turn off move const internal for any constant that has just 2 bits set or 2 bits off. And then we ran in all kinds of, this bit test expansion that I've got a pass from Raphael, I need to review it. As I said, there's probably more things that I haven't found. I look at spec, I look at the assembly code and go, that needs to be fixed, that needs to be fixed. I fix a few and then I get dragged off into another problem. But it is work in progress. All right, Robin, hopefully I didn't take too long. Actually, I should say, any questions? All right.
Did you just hold this?
Oh, I put that on and I guess I held that the whole time.
Okay. Should I? Yeah, I'll just try.
tackle him on his way out.
Very good. Sounds like a plan.
I'm a small guy, but I love tackling people.
So I guess that's not actually vector yet, but it's just like, oh, it is. Yeah, but not everything of it. So that's, after the deep dive, that's more like of things that changed since GCC 14 and 15, or what's still ongoing. One important thing that I also noted in the RVV talk yesterday is that we now have an option to allow misaligned vectors by default when the default, or not by default, but change the default from not allowing misaligned vectors to allowing it by this no vector strict align option. And that allows us to just vectorize much more, like especially X264 prime example. The other thing was a bit controversial, or still is. So suppose you have like a makefile of a project that specifies a default march. Let's say march RV64 GCV with 128-bit vectors. But you now don't want to compile with that default or for that default, but for your own CPU. Usually what you do is specify mCPU equals your CPU. But due to our precedence rules, mCPU doesn't override the arch part of march. So what are we going to do? My suggestion was,
Fix the backend. That's just a bug.
of course, I mean, no, it's not a bug. Wait, it's not just a bug because LLVM does it that way and they decided for it. So my idea was, let march take a CPU string. Power doesn't use march, but mCPU, but you use that in place of march, basically, right? I'm saying you because you were power. You're not anymore. You're the only power person.
He does back there.
All right, Segaris, right. Okay, so march is basically march plus mCPU then. That was my idea, but it wasn't so well received on the LLVM side.
You said, wait, you said march is what?
As mCPU. Basically, march can now take a CPU string versus just an architecture string. So you can specify march equals Ascalon or Ventana, and so on. This is already in, but we might need to revert it depending on how the discussion goes. So we still have like 6 weeks or so. So like the ARch64 solution is have an march unset to...
That's ugly.
Yes, I agree, but LLVM does it, and there is...
Still ugly.
And I still agree. But, well, free to join the discussion. So, that's just the way it is. So that's the other option, march unset, and then use mCPU the way it was used before. So this doesn't change any, precedence rules, but you just...
Why isn't an mCPU just override what the march does if it comes later?
I mean,
it seems
yeah,
like it should just
this
come
question is
the later one on the thing.
Yeah, it's just documented in there. I would like to change it, but
Yes. I would vote for that.
So ARch64 also does it that way, but what they do in addition is they warn if there is any non-overriding behavior or overriding behavior. We should at least do that. I have it on my to-do list, but I just couldn't be bothered yet. So that at least would improve the status quo.
Maybe an option to give them the old behavior if they wanted it or something?
MRH2?
I would do.
Like
No. I mean, dash M,
So- So we all agree
I
this is...
love the bad old behavior option. And
I
I'm an
also
idiot.
prefer the old behavior, but
Not alone, Peter.
so
But
still,
you're
I mean,
also-
it is a controversial discussion here, and there's no real right solution, there is a right solution for everybody individually, but not for all of us. So yeah, that's just the way it is. It's still under discussion, and in favor of the LLVM rule is just that we would be compatible with them. So, and we don't want to introduce any more incompatibility when everything else is already that complicated for us, the architecture strings and that. So, well, that's the status right now.
And that compatibility question is a big deal for the distros. They really want to see us be as compatible as possible, beyond just ABI questions. It goes into this stuff.
Yeah, I mean, if I'm making that argument, it's just a boilerplate. Don't mess with command line arguments because some distro guy will yell at me.
Yeah.
I told them
sure.
10 years ago that I was not going to mess with them.
Just the way it is.
But do we care what the distros are doing right now? I mean, are we not like RVA 23 is basically our baseline?
So,
and going
let-
forward from there is we
So,
should set our
let me-
we should set our
just
line
continue
here, and then we have compatibility after that. But we
Unfortunately, not every distro's gone RVA 23.
yet.
I'm not convinced.
This
it's
is
definitely
an
studying
RVA
more.
23 thing. This is a command line argument thing, right? It's not like I'm fundamentally opposed to it.
So, yeah, that's here. The slide here is
Let's go forward.
just for people who are not too familiar with our architecture strings, they are lengthier than everybody else's architecture string. So what is introduced now with 16, right?
Yes.
Not 15, is that you can specify an RVA profile that basically mandates all these individual extensions and use this as the default. And once the default is sane, you probably don't need to override as often, and the problem I showed before is not that pressing anymore. Still, it will still be there, but we improved on it quite a bit. So that's what we have now.
What I'm afraid of, Robin, is we're going to put that in there, and then we're going to have somebody using the unset because there's one of these that doesn't work on their design.
Yes.
It's going to happen.
We also, I mean, we thought about having like a MRH minus, so to take away anything from what you previously specified, but it's going to be ugly as well.
so much time on march string parsing command line argument stuff like
That we're Turing
just going
complete.
crazy. Yeah.
Yeah.
Right. Like
Yeah,
we just need to pick something.
yeah, right. I mean, we just need to go ahead. Like,
And I
yeah.
think your argument, Palmer, that I agree with is that, you know, if somebody says we're RVA 23 compliant, then, and they use this, then they're going to get the full string.
We are going to have vendors who say they're RVA 23 compliant.
Except,
don't do
yeah.
some of this stuff.
Yep,
Yeah.
and that
Have
is
that
their
RVA
problem.
22,
Yeah, well-
RVA is not going to force it for RVA 23, but then they just get what they asked for.
Yeah.
Their code doesn't work.
Yep,
that's
and it
fine.
blows up, and that's going to be the only motivator for them to fix their bloody
I
design.
think and this is what we talked about earlier, is I think we are shooting ourselves in the foot by supporting all of the broken stuff, right? We're kind of now with like this lowest common denominator where like the only thing that works is the stuff that no one's managed to break. So we're kind of like penalizing
But
all of the
right now
people.
we're not talking about supporting anything broken, but just to improve on like our command line arguments,
But
right?
but this is the same for say like, you know, I guess we're going down the rabbit hole of like the, you know, MTune
Yeah.
generic type stuff with the
Sure,
misaligned
yeah.
accesses,
Like
right?
I
Yeah.
would just say we have what we have and
Command line
let's
arguments, yeah,
continue.
whatever.
Yeah, right.
Pick
Just,
something.
yeah,
Do it.
pick something, exactly.
Yeah, just keep in back of your mind, of course, there's also all the embedded space, and the embedded space is completely different. So you don't want to do anything that wrecks all the people doing their custom RV32.
Yeah, they can still type
Yeah.
them.
Yeah, you can
Yeah.
still.
Yeah.
Yes.
I'm just
They can
yeah.
offstring their CPU description or
Yeah,
whatever.
I know.
Yeah, so it should still work.
Well, that's
Yeah.
I think an embedded profile is going to be too
So,
custom, but
yeah.
it's a possibility.
Like the question before,
everybody wants to leave their
So,
the question before was just, we have a makefile or anything, a project specifies some baseline, whatever it thinks is correct, and we want to override that. That's a valid use case. Everybody does that.
But I think we just need to define rules,
Yeah.
LLVM
Right.
has rules that they've defined and want to stick
I
with.
think we should
Match
stick
the
to,
LLVM rules.
it
If
might be
they're-
ugly and many will agree, but I think we should
I
just be
also think they're
compatible.
ugly.
Yeah, most will agree, but
But we-
whatever.
I
I
think
mean,
we should just
compatibility is
do-
also like a
That's it.
value in
I'd
itself.
rather have ugly and compatible
Yes.
than
Yes.
pretty and also even the pretty one's ugly. So who?
Yeah,
this is going to be a
Everybody
pain point forever.
yeah. So we like.
We should probably keep going.
Yeah, let's get going. So just a bit of vectorizer like things that we added. This slightly overlaps with what I said yesterday, but not everything. So let's just go ahead. Like in GCC 15, we added vector crypto extension support. That was ratified 2023, so we're actually not far behind. Which adds some very important like primitives like vector pop count, CTZ, ZLZ, and so on, and that also help like auto vectorization, obviously. Then we have with 15 initial early break vectorization support that Tamar added initially for 14, just for AR64. For us, it works now. There are still some rough edges, and several of the topics Tamar touched on in the vectorizer BoF and in his talk are also relevant for us and will improve code gen for us. Then we have improved permute synthesis, especially with the slide ups and slide downs. This helps X264. We have our support for even, odd, and interleave permutes, which are very common in the SLP vectorizer. We implement this via vcompress, which is not pretty, but it works. Maybe we'll get some real even, odd, and interleave patterns in the future with some future extension, but so far, like we have that band-aid.
Yeah, I have seen zip unzip.
Yeah,
kinds
zip
of
at least, that would help.
extensions.
Yeah, that would help. I mean, and then we have improved mem, whatever routines on the vector side, particularly regarding elmo selection. That's what Craig did from your team. Yeah, and these are this is just a small selection of things that happened. This one, most of you have seen yesterday, probably already. So the vectorizer expects that inactive masked out elements must be 0, but ours are not. So they're actually a question mark. And what there's some typo in there. So what the vectorizer does is, of course, just use a 0 and merge with the mask we have to create the proper 0 values, if it needs to. That's happened in GCC 15 as well. Some miscellaneous improvements. The first one is funny, or not so funny, because we have such a large number of modes for vector due to our Elmo situation. The ins and emit file blew up. At some point we were at over 30 megabytes and it became a huge bottleneck for compiler build times, like, I don't know, 20 minutes, 30 minutes in some machines. So we needed to teach GenEmit and GenRecog to split up their outputs. It's not very difficult, it's just different to before. And this change also helps other backends. x86 wanted to do that for years, I think. So now we have that. The next bullet point is the VZVL pass has been, like, it's special to us and helps us, Jeff talked about this yesterday, helps us place VZVL strategically nicely, hopefully mostly correct. But the correctness part was, well, not always true. So we had at least 10, 15 individual VZVL pass bug fixes. One went in really late in the 15 cycle, so I don't know, like 1 week before branching. Well, but we managed, and now it's in a pretty good shape. I haven't seen
I haven't seen a correctness in a while.
Me neither. So it.
I think the last correctness I saw was like an AVL propagation, not
yeah,
VZVL.
I mean, that's related, of course, but yeah, we can make the distinction. So it wasn't a VZVL issue.
Correct, are there any issues with maybe redundant ones?
Are there issues with redundant VZVLs?
Yeah, definitely.
Almost certainly.
Yeah, no, definitely.
I've seen several.
Yeah.
That is a problem I think we're going to have to tackle once we have silicon showing up. Because one of the things we can do is we can adjust how the scheduler pulls items out of the ready queue. And right now, I've got a patch that will allow us to track vector state. And as you pull an instruction out of the ready, when you're ready to pull an instruction out of the ready queue, you can ask, is it the same vector state that you last issued? If so, pick that instruction. Otherwise, pick something else. But right now, it only does it if all the instruction, from the set of instructions that have the same ins in priority. They have to match exactly. And my suspicion is we could probably relax that.
Is that really what we want to do, though? So, I mean, let's say we have a very expensive vector instruction, and we move it up because it matches the VZVL, but it puts a register dependency really close to each other, and it has to stall, where it might have been better to leave the add another VZVL and the other instruction to give it some space between those.
That's absolutely a valid concern, and that is why right now it only does it if the ins and priorities match exactly. That is precisely the problem. And so I want to have hardware to know how to tune that knob and say, how many degrees of freedom do I have?
And also how much we care.
And how much do we care?
That's going to be,
How much
like,
time we should
yes,
dump into
yes.
VZVL
Yeah.
manually.
We might have already dumped too much time into it, but we don't know. And like, the hope is that over time this will become a lesser problem, and most microarchitectures just won't care too much, except if you go bonkers.
So Palmer's question was, have we spent too much time on this? And I think Juzi would say for their design, they want to eliminate every VZVL that they can. I mean, I don't have a clear understanding of why yet.
VZVL, like, optimization is also pretty much an icon-driven optimization.
You're
because,
probably right.
Like, they just show up, but they might not matter.
Yeah, they typically don't matter a lot on our design.
I think we need hardware, and we need to get out of the first generation hardware. with
Yeah.
performance
I mean, that's
modes
just
mode
it.
Before we really decide if this is a worthwhile place to dump.
Yeah.
I totally agree with your statement, Palmer.
I
That
think doing this well would be a big thing.
yeah. So for the record, Palmer's statement was we need to go away from the evaluating this on V1 designs or with iCounts and do it on where hardware is going to be going forward as opposed to where it is today.
So just some more bullet points here. What's currently in progress for GCC 16 is, the first bullet point is already in. So we now do proper alignment checking for gather-scatter element alignment. That's what I also covered yesterday. We want to make better use of strided loads and stores in the vectorizer, basically have like them as first-class citizens. And that's also in progress. Will most likely, hopefully, still go in to 16. The next thing that also went in is vector broadcast improvements. That's mostly a correctness issue, not so much a performance issue, but we had ICEs there. And make the zero-strided load idiom tunable. That's what Paul-Antoine mentioned. We can actually broadcast a memory operand into a vector. We just might not want to do it. So right now we don't have the option to choose between wanting or not wanting for certain like constellations, and we at least want to allow tunable to select between both choices. So right now it's just not there.
I thought we had a tunable.
Yeah, we have a tunable.
Oh, we just
but
haven't wired
yeah,
the
it's, no,
query.
it's wired. Everything works except two small cases
Oh, okay.
that Paul-Antoine mentioned. So in general, it's possible, just not for 100%, but 90.
I've seen the back end generating a lot, or on some test cases, segmented loads. Are we doing anything to try to get rid of
Oh, well, like
segmented loads
yeah,
if we can?
Costs to infinity. I mean, Jeff actually wanted to start a discussion of disabling them altogether, just like Rivos is doing. Yeah, I know, it's upstream. You can say no segment, vector segment. So, but
The cost penalty. Edwin recently had a test case that shows that the severe cost penalty is insufficient. We're still generating segmented stores.
And increase the cost.
And the bigger hammer is to just
yeah,
add a,
I mean,
yeah.
like you can crank the cost so high that it won't vectorize. I mean, that's possible. You just set it to 1,000 or so, and then it will work.
But can we still vectorize, but just without the segmented load?
Well, so the question is, will it vectorize without segment loads? It depends on the overall cost, as it
And
should.
the issue is that, like, we're doing this, segmented loads are a bit special in the vectorizer in that we choose very early on, or that we look very early on, do we have segmented loads? If so, go this road. If not, go the other road. So we kind of lose some vectorizer choices by going the segmented load. So if you disabling them altogether, you go the other way right away and have different choices.
The big hammer I was talking about is this predicating the vector modes for the segmented load and store so that the patterns just don't exist if.
Yeah, just like no AutoVec segment, right?
Yeah, so that was one of the proposals I wanted to discuss today. Was should we disable segmented and indexed?
So if I'm
For
looking
all or a
at
subset of
your
architectures?
numbers,
It's-
I wouldn't
it's an open
disable them.
question.
No, you, Peter, you. I mean, these Ascalon numbers we talked about, they're pretty good for segmented loads. And
I think we should support disabling.
But even so, I know we have some benchmarks where we saw the segmented load, at least for some of the benchmarks.
I mean, so
Well, you might have the best segmented loads I've seen so
yes,
far.
that's what we just meant. So
Until I
And it
got
still
here,
could be a problem.
until I got here and saw some of the data, I was ready to say we should make them both go away, segmented and indexed.
So
I think
in
your
general, a
design
segmented load
might
is a
have
very,
segmented that works.
very expensive operation. No way around that. It touches several lanes, several vectors and all. It's never going to be cheap. But in my opinion, that's a costing decision. Plus this issue with the vectorizer just losing some options. And right now we could make that as per CPU tunable. I think it's possible. It's just not there yet. But if somebody wants that, they can put it into their tuning structure and be okay with it.
That's just syntactical decoration, right? It doesn't matter. The code gen supports disabling it, whether you do it per CPU or.
Yes, I mean, it's all the same. It's all the same.
And it's in the vector cost structure. If you
Yeah.
crank those costs, we've absolutely seen cases where we had segmented loads and they go away.
And the same issue is with indexed loads. They're also very heavy, maybe even heavier at some point, because they don't load successively. But my idea or my way would be to crank up the costs.
And
make
that does work.
Make the cost dependent on maybe the number of units or whatever your microarchitecture wants or like is dependent on for those cases. So disabling stuff.
I think I agree with like the theoretical, we should cost things. Right?
I mean, yeah, I guess,
I
yeah.
think what Greg is saying is that probably bugs and cost.
There is a bug, yeah. There's maybe a bug, so he has cranked it up, the cost part.
Yeah,
Yeah.
he's papering over the bug and we should also be debugging
Okay, then let's open a PR. I mean, if it's a bug in the vectorizer, we need to fix it.
Yeah.
We've got real issues here.
Yeah.
Yeah.
Yeah. No, if it's a bug, it's a bug, right? So no way around it. Okay, so not much more I want to talk about. Like what I initially wanted to do as a promise to the Rivos guys is not also for us, obviously, it's for everybody. So like this setting a fixed vector size is a benchmark option, obviously. If you want the best performing vector code, you set a fixed vector length. And this MRVV vector bits equals ZVL, so it will equal to the ZVL you specified. That will give you the exact vector length and nothing else. And the code won't be compatible, it's no VLA anymore, it's a basic VLS setup. And this code gen has kind of a severe bug right now in that it cannot properly handle the transition from VLS modes and VLA modes, while in this setup, VLA modes are actually VLS modes. It still thinks there's a distinction because it goes by name. It says, oh, it's a RVV, M1, whatever, VLA mode. It's no VLS mode, and then we go totally haywire. So that's just a bug right now that I'm trying to fix, but it has like implications all over the place. Our gathers are not specified properly. This is why I'm going to clean up the gather-scatter RISC-V target support. And in order to clean that up, we need vectorizer changes. So it's a bit of a rabbit hole.
I think you've only got maybe 5.
Yeah.
So for this, when you say when we specify the basically VLS mode in our width,
Yeah.
are we actually going all the way, almost like acting like this is power and I
Yes.
always do that length, or
No, so
we're
we
not
still
using
have-
some of the
We still
the
have length masking and
Okay.
the masking and
Okay.
all that. Of course, we won't throw away that. So it's still length masked, but it's just that the vector size is always that or smaller, just not larger, something.
It's the maximum number, the minimum is
Yeah.
from the arch string.
Right, the maximum, minimum.
No,
stuff.
it's minimum equals maximum. So
Oh, yeah.
but
It
obviously
is a vector length.
on a VLS architecture, you can just use one element of your vector. That's always possible, right? So it's just not compatible. It's just for this exact vector length. That's how we do it, and that's the plan. I hope that it will still be okay for 16, but it will be tight. So, as I said, rabbit hole here. And yeah, more VZVL improvement. That's kind of a generic statement. We always want to improve it. But
I think the at least the immediate to do there is to decide whether or not to upstream my patch for the scheduler stuff. That's still internal.
Yeah.
When I last looked at it, when we first wrote it, it was for SATD in X264. When I last looked, it didn't make a bloody bit of difference anymore.
Yeah. Well.
Curious how much benefit you got from it, since from sci-fi, we've also tried it on the L-based side. I mean, kind of we type awareness scheduling, but we don't see too much benefit, so we mostly discarded it away.
The VZVL stuff?
Yeah, I mean, yeah, for the schedule.
Yeah, my recollection, it's been just short of a year since I looked at this problem, is this time last year we were fighting for every cycle because Rob and I were not happy with the performance of the code. And that's what got me looking at this problem. I think today SATD with the strided loads runs pretty well in our design. And so we have very much stopped looking at the VZVL problem. But I was looking like, I can save one cycle. I'm doing it.
Right. So yeah,
It's just
not yet. 5 minutes.
Okay.
just a general comment on of these things here. I'd encourage you to, do more iterative compilations where you change all the flags around, because it's enough expose where the compiler's going wrong. That's where Craig's stuff came out of, was doing combined elimination on spec CPU. And you suddenly find, why does changing this one heuristic a tiny bit halve the number of instructions? And it does make stuff pop out as a general technique for exposing what's wrong.
Yeah, and I think the biggest impediment to doing that in a more systematic way right now, lack of good hardware.
Oh yeah. I think most of Craig's thing is trying to the heuristics to get it through whatever you've got.
We are getting there.
Yeah.
Any other questions? Nobody's fallen asleep yet. Are we all done?
4 minutes to spare. How efficient.
4 minutes more time.
You don't have to run. You can stroll to your taxi.
Thank you.
Thank you.